The dark side of the moon. No, I'm not talking about the dark side of the moon like the Pink Floyd song, as awesome as that song is. I'm talking about the actual and literal dark side of the moon. When you look up at the sky at night and sometimes in the morning, you see the moon illuminated. But you'll notice, if you pay attention, that picture of the moon we see is always the same, regardless of whether it's a crescent, half, or full moon. It's just sections of the same picture. The other side of the moon is never visible from the Earth, and thus it's been dubbed the dark side of the moon, making many people think that the moon never gets sunlight on that back side. Well, that's not exactly true. You see, when we see the moon, we only see one side of it. That's because the moon rotates on its own axis at the same rate that we do on Earth. This is known as being tidally locked with an object. The sun emits its light onto all sides of the moon as it rotates around, but because of position and rotation, we never see the other side. The other phrase for dark side of the moon refers to space missions, where spacecraft can't receive messages from the dark side of the moon, due to the moon quite literally blocking signals from Earth. So while you could still use that phrase, especially when talking about the Pink Floyd song, use it correctly, okay? Drift away. In case you somehow didn't know, the moon stays in orbit around the Earth because it's within Earth's gravity pull. The bigger the object, and the more dense it is, the more gravity it exerts, which is why the moon is stuck where it is and why it's in a perfect orbit around Earth. But a mysterious thing is going on with the moon, one that will eventually be bad for the Earth. Mainly, the moon is quite literally drifting away from our planet. How does that work? Well, it has to do with gravity. While the Earth's gravity is stronger than the moon's, the moon has 1/6 Earth's gravity. That doesn't mean the moon's gravity doesn't affect it. Just the opposite, in fact. The moon's gravity slows down the Earth's rotation, and the Earth's counter effect extends the orbit of the moon. These two opposing forces delivers a result where the moon is moving away from the Earth at a rate of 4 centimeters every single year. Now, before you panic, do remember that 4 centimeters isn't even 2 inches, and even over the course of a decade, that doesn't amount to much. However, eventually the moon could be far enough away from the drifting to cause problems. Remember, the moon affects our tides and currents in the ocean. The farther or closer it is from the perfect orbit, the more the Earth is affected. Still, for a long while, we'll be okay. The moon is a burial site for one man. When you think about the moon as a whole, you'll note that because no one lives on it, there's a lot of space that can be used for many things. And there are many people who honestly wish to be buried on the moon. Some government agencies have even proposed the idea of turning it into a burial ground at times. Obviously, this hasn't happened yet. However, there is one person who is indeed buried on the moon in the loose sense. That would be the late astronomer and geologist, Dr. Eugene Shoemaker. Now, don't get the wrong idea. He didn't go to the moon and die there, but rather his ashes were put on a rover that launched to the moon in 1998 and in 1999. It landed on the moon and thus spread his ashes there. And by spread, I mean it quite literally crashed there. What a way to honor a guy, am I right? The temperature is very inconsistent. If you think about Earth, you'll know that various places on the surface of it, and even in the oceans at times, have a wide variety of temperatures. It depends on the area and the exposure to the sun. The moon doesn't have that per se, and yet when you get temperature readings off of it, it's all over the place. For example, just the lunar equators, the average temperature can be low as minus 280 Fahrenheit and can rise up to 260 degrees Fahrenheit. That's a big swing, and a big reason why the astronauts wear temperature-resistant suits when walking on the moon. And when an eclipse happens, in the course of 90 minutes, the surface of the moon can drop in temperature by 500 degrees. That's a very quick drop, and something that hasn't happened on Earth in a very long time. The fact that this happens on the moon at all further shows just how different it is from our planet, even though some think it came from our planet. The origins of the moon. When it comes to the origins of the universe, there are a ton of theories and debates about what created everything. Was it a cosmic coincidence? Was it a divine creation? The answer depends on who you talk to, but the origins of the moon are just as perplexing, because we honestly can't definitely tell you how exactly it got there. But one of the biggest theories of the lot is that the moon actually came from the Earth itself. Basically, billions of years ago, before life had started to grow on the planet Earth, a meteor of great size struck our planet. When it did so, a large chunk of the Earth got blasted off into space, yet got trapped in our orbit and thus became the Moon over time. One of the reasons that many scientists believe this is because the rocks on the Moon that were studied after being collected during the Apollo missions were found to have oxygen isotopes that were identical to the ones we have on Earth. That's one heck of a coincidence. Granted, there are still a few questions around this origin story. Mainly, how did the Moon get so perfectly spherical in shape? Where did the chunk that became the Moon come from in regards to the Earth itself? The obvious answer is it came from a part that would later be a deep ocean, but it's hard to tell. There are many other theories as to how the Moon became the Moon, but this is one that gets scientists the most intrigued. There's a unique water cycle on the Moon. If you recall, I noted earlier that the Moon has some rather violent shifts in temperature depending on its position and the time of day. One of the effects of this is having a rather unique water cycle going on. Yes, there is water on the Moon, and not unlike Mars, it's the frozen kind. There are layers of ice on the Moon, and we've known this for a while. However, when we were able to observe said ice in 2009, we found out that it'll be ice for one part of the day, then it'll get warmer on the surface and quite literally melt and rise up into the atmosphere. There it'll travel and move around the Moon until it gets cold once more, falling to the surface and becoming ice yet again. This, of course, is not too dissimilar to the water cycle on Earth, save for the fact that the swings in temperature aren't nearly this severe. However, there is a potential benefit to this. Water on the Moon could be useful if we colonize it, and the rovers we send to the Moon can take this water and turn it into rocket fuel. Crazy people were named after the Moon. In pop culture today, and in people who believe in superstition, there is a fear of a full moon. Not just because it's a bright white bulb in the sky when you can see it, but many people have believed over the years that there is a power in the full moon. And no, I don't just mean turning into werewolves. Ever since the Middle Ages, it's been documented that people act weirdly under the power of the full moon, as well as having a wide array of mental issues. This eventually led to a certain term for people who had these issues during this phase of the moon: lunatics. Yep, that word came because of the moon. I personally don't think it would appreciate being used as a slander term, but oh well. It also should be noted that people track the deaths, births, and other conditions that are reported on full moon days and nights just to see if there are any increases or decreases from the year before. The supermoon. If you want to know what is scarier than a full moon, you need to talk to fishermen, because they know that there is a phase of the moon that scares them to their core. The supermoon. No, this isn't another moon that magically appears in the sky. Rather, this is a phase of the moon due to its orbit, which again is drifting away, where the moon gets closer to the Earth than it does for many years. Why is that mysterious? Well, much like people fear the moon, people fear the supermoon having a bad effect on the Earth. And this time they're right, because the closer moon brings a strange effect to the tides and currents of the ocean. An episode of the show Deadliest Catch showed the boats of the fleet being ravaged by the supermoon, and one man almost lost his life after being accidentally tossed overboard while the supermoon was out. Oh, and that incident happened right after that crewman's captain mocked the supermoon. Not smart. Moonquakes. What, you thought that the Earth was the only place that knew how to shake? Well, you're wrong. The moon also has seismic activity, appropriately called moonquakes. What's ironic here, though, is that the moonquakes are caused by the Earth and its gravity pulling on the moon. So sorry about that, Moon. Another couple of key differences is that while the moonquakes are much weaker than earthquakes, typically, they go much longer. Earthquakes can last a few minutes, but moonquakes, they can go over a half hour. Not a trade-off I'd want to make. There's a lot of trash on the moon. Now, before you go and make a note about how we need to keep the moon clean, let's have some context here, alright? The reason for trash being on the moon is because of the various missions to it, both manned and unmanned. When Apollo 11 came to the moon for the first time, Neil Armstrong and Buzz Aldrin had to dispose of trash from their craft to help make it lighter. Subsequent landing parties had to do the same thing. Every pound counts on those vessels. Speaking of vessels, probes, moon rovers, vehicles, and more were left on the moon because it would have risked the astronauts' safety to try and bring them back to the shuttle and beyond. And of course, there are some non-trash items left on the moon, like the American flag and a retro reflector which helps send moon data back to Earth. Moon shadows are darker. I know what you're thinking. How does that work when the sun is the source of light for both objects? It's simple. While the Earth has an atmosphere, the Moon doesn't. The atmosphere of Earth protects us from various things, but it also scatters the emitted light so we only see things a certain way, which is why many people think the sun is yellow instead of white. For the Moon, though, it doesn't have that. It has no atmosphere, so the light is more purely put into the Moon, meaning that the shadows are a more pure shade of black than they are on Earth. Moon dust can kill. No, I'm not joking here. This was almost proven in the worst way possible. While it's true that the Earth and Moon have many similar properties, one of the biggest differences is how the ground particles that make up the surface are shaped. Our ground is soft because of the water, and thus it isn't very harmful. But on the Moon, with no atmosphere, the components of the ground are sharper. Much sharper. So much so that astronauts told NASA that the moon dust was actually tearing into their moon boots and even messing with their visors. Harrison Schmitt from the Challenger flight actually inhaled some moon dust while he was back on the ship, and it almost killed him via lunar hay fever. The moon dust was later studied and revealed to be capable of killing lung and brain cells. The United States thought about blowing up the moon. I wish I had been in the room when that happened. I want to hear the discussion of, hey, why don't we try and blow up the moon? To be clear, this did happen in the 1950s. It was in the midst of the Cold War, and the US was losing to Russia in virtually every way that mattered. Back then, the idea of a show of force was more palatable than taking a loss to the Russians. So mere years after creating atomic and nuclear weapons, they thought about blowing up the moon to show the Soviets that they were still top dog. This was called Project A119. Now, looking into the project state that it was more of a thought experiment, but some have to wonder if that's true.
Transient light phenomena. These are among the most exciting and enigmatic mysteries observed on the Moon. These events are bright flashes that appear on the lunar surface and are characterized by briefness and high luminosity. Transient light phenomena has been observed for centuries, but only in recent years have accurate images and data been captured for study. Despite advances in lunar technology and exploration, what causes these flashes is still unknown. One of the most accepted theories is that meteorite impacts on the lunar surface produce transient light phenomena. These impacts generate a lot of energy released in the form of light. However, scientists have also observed flashes that do not appear to be related to meteorite impacts, suggesting that there may be other causes for these phenomena. Another theory is that electrical discharges produce flashes in the lunar atmosphere, which, although very faint, exist. Studying transient light phenomena is essential to understand the Moon and space better. Furthermore, these flashes may have important implications for future exploration and colonization of the Moon. Although much remains to be discovered about this mysterious phenomena, researchers continue to advance thanks to constantly improving technology and space exploration. Lunar exosphere. Believe it or not, the Moon has an exosphere, the outermost layer of the lunar atmosphere located around 1,000 kilometers above the lunar surface. Unlike Earth, the lunar exosphere is highly tenuous and mostly comprised of charged particles known as ions and electrons. The lunar exosphere is a hostile environment exposed to solar radiation and solar winds, which can affect its composition and dynamics. The ions and electrons in the lunar exosphere result from the Moon's interaction with solar radiation and winds. This is a place of great interest to scientists because its study can help understand better the interaction between the Moon and outer space and the atmosphere of other celestial bodies. Furthermore, the lunar exosphere may have important implications for future exploration and colonization of the Moon. One mission that has helped study the lunar exosphere is the Lunar Atmosphere and Dust Mission Environment Explorer, LADEE, launched by NASA in 2013. The LADEE mission was designed to study the atmosphere and dust environment on the Moon, including the lunar exosphere. The data collected by the LADEE mission have helped improve its understanding and importance for space exploration. Volcanic activity. Although volcanic activity on the Moon is considered extinct, there is evidence that the Moon was once a much more active and tumultuous place. Volcanic activity on the Moon is believed to have begun about 4.5 billion years ago, shortly after the moon's formation. During this period, the moon was struck by meteorites and other celestial bodies. The energy released by these collisions caused the interior of the moon to melt and lava and volcanic gases to escape. Although most volcanic activity on the moon stopped about 3.5 billion years ago, scientists can still see the evidence of it in the form of impact craters surrounded by deposits of volcanic material. Furthermore, volcanic gases in lunar rock samples suggest volcanic activity on the moon could have continued until about 1.2 billion years ago. Volcanoes on the moon are very different from those on Earth in that they are not cone-shaped and do not emit ash, but are flatter, and the lava that erupted from them millions of years ago stretched for thousands of kilometers. Volcanoes on the moon are also bigger than those on Earth due to a lack of erosion by water and the atmosphere. The moon has no magnetic field of its own. Unlike the Earth, the moon does not have a magnetic field. Earth's magnetic field is generated by the dynamo in the planet's outer core, where the movement of liquid iron produces electrical currents that generate the magnetic field. However, the moon does not have a liquid core to generate a magnetic field. Instead, the moon is surrounded by Earth's magnetic field, which extends to the moon as a magnetic tail. This is due to the interaction between the solar wind and the Earth's magnetic field, which produces a zone of magnetic influence called the magnetosphere. Earth's magnetosphere extends beyond the moon, so the moon lies within its magnetic field. The absence of an appropriate magnetic field on the moon has several consequences. First, the moon's surface is more exposed to the effects of the solar wind, which can erode and change the composition of the lunar surface. Second, the lack of a magnetic field also means that the moon does not have a significant atmosphere, since a magnetic field helps retain an atmosphere around a celestial body and prevents gases from being swept away by radiation from the sun. Helium-3. Helium-3 is an isotope of helium that is believed to be an ideal fuel for nuclear fusion. Unlike nuclear fission, which produces radioactive waste, nuclear fusion is a cleaner energy source. Helium-3 is a desirable fuel because it does not produce neutrons in fusion, reducing radioactivity risks and making waste less problematic. The moon is believed to have large reserves of helium-3, which was accumulated on the lunar surface over billions of years by the solar wind. Helium-3 on the moon is found at a concentration of 5 to 10 parts per trillion, meaning there are about 1.1 million tons of helium-3 on the moon's surface. Extracting helium-3 from the moon could be a cost-effective and sustainable way to obtain fuel for nuclear fusion. However, the technology needed to extract and transport helium-3 from the moon is not yet developed and would be expensive. In addition, there is no established commercial market for helium-3, so the economic feasibility of the lunar extraction of helium-3 has not yet been explored. Despite these challenges, the moon's potential as a source of nuclear fusion fuel has been the subject of interest from governments and private companies. Exploration and exploitation of the moon's resources, including helium-3, could play an essential role in the future of clean and sustainable energy. Cold earthquakes. In 2009, NASA reported that data collected by the Lunar Reconnaissance Spacecraft Orbiter, LRO, indicated the existence of a phenomenon known as a cold tidal wave on the lunar surface. This phenomenon occurs when the temperature of the lunar surface changes dramatically in a single lunar night. The moon has no atmosphere to retain heat, which means its surface temperature can vary wildly. During the lunar night, which lasts about 14 Earth days, the temperature on the lunar surface can drop to minus 173 degrees Celsius. During the lunar day, which also lasts about 14 Earth days, the temperature can rise to over 100 degrees Celsius. However, the LRO data indicates that the lunar surface temperature can change dramatically in a single lunar night. This is because craters and mountains on the lunar surface can block sunlight and create rapidly cooling shadow areas. The temperature in these shaded areas can rise dramatically when the sun rises again after a lunar night. The rapid temperature change can cause the lunar surface to crack and break, causing a tidal wave-like effect. The cold tidal wave on the moon reminds us of the complexity and diversity of geological processes that occur in our solar system. Although the moon may seem like an inert and lifeless place, It is a busy, fascinating world full of mysteries and unique phenomena. Meteoroid Swarms. The Moon is exposed to constant meteoroid impacts as a celestial body in our solar system. These small rocky bodies drifting through space can collide with the lunar surface, leaving craters and scarring the surface. However, meteoroid swarms exist on the Moon in addition to individual impacts. These swarms are groups of meteoroids that travel together on a standard trajectory, increasing the probability of impacts on the Moon. Meteoroid swarms on the Moon can be caused by various factors, such as Earth's gravity, gravitational interaction with other celestial bodies, or proximity to near-Earth asteroids. These swarms can last from a few days to several weeks and can be high enough in density to be detected by lunar orbiting scientific instruments. Meteoroid impacts can provide information about the composition of the Moon and the frequency of impacts in the solar system. In addition, studying meteoroid swarms on the Moon can provide valuable information for space exploration and the protection of astronauts on future lunar missions. Pits. The pits are a unique geological feature of the Moon. These are small, deep craters with no raised walls or rims like typical craters. Instead, the pits have a flat structure and a depression in the center. Pits are formed when the roof of an underground lava cavern collapses, leaving a depression on the surface. These lava caverns are believed to have formed billions of years ago when the Moon was still geologically active and volcanically active. These craters are difficult to detect from Earth due to their small size and flat shape. They were first discovered in 2009 by the lunar reconnaissance spacecraft NASA Orbiter. The study of the pits can provide valuable information about the geology and evolution of the Moon. Most of the pits are considered in regions with volcanic activity in the past, suggesting that the Moon was geologically active for a long time. In addition, the pits may also be necessary for future lunar missions. Some of these craters may provide a natural shelter for astronauts and their equipment, shielding them from radiation and extreme temperature fluctuations on the lunar surface. They can also be used as locations for exploring underground caverns and studying the composition and internal structure of the Moon. Moon rocks on Earth. Moon rocks are of great interest to scientists, as they contain valuable information about the history of the Moon and the solar system. Since the Apollo 11 mission brought the first sample of lunar rock to Earth in 1969, about 382 kilograms of lunar rocks and soil have been collected. However, the rocks brought to Earth by astronauts are not the only ones that come from the Moon. In 1979, on Antarctica's frozen continent, the first lunar meteorite, Yamato 791197, was discovered. These meteorites, also known as lunar meteorites, are fragments of lunar rock or soil that were ejected from the Moon by meteorite impacts and traveled through space before falling to Earth. No specific crater provenance of any lunar meteorite has been positively identified. However, a study revealed that the Sea al-Uhaymir 169 meteorite could come from the 25-kilometer diameter Lalonde impact crater south of the Moon. Lunar meteorites are important to scientists because they offer a unique opportunity to study the chemical and mineralogical composition of the Moon without the need for a human crewed or robotic mission. Additionally, lunar meteorites can help scientists confirm the age and geological history of the Moon. More than 300 lunar meteorites have been found on Earth, with weights ranging from a few grams to more than 18 kilograms. Most of these meteorites have been found in desert regions such as the Sahara and Antarctica, where they are easier to spot due to their dark color and relatively large size compared to other meteorites. Earth light. Earth light, also known as Earth glow, occurs when the Earth reflects sunlight in the direction of the Moon. This occurs when the Earth is in its complete phase and the Moon is in its new moon phase. The effect is a faint but visible glow on the lunar surface. Earth's glare doesn't affect the Moon much since the amount of reflected light is minimal compared to the direct sunlight the Moon receives. However, the phenomena is interesting to astronomers and scientists studying the Moon, as it can be used to determine the reflectivity of the lunar surface. Additionally, observation of Earth's glow can be used by astronauts on lunar missions to determine their position on the lunar surface. By looking at the position and brightness of Earth's glow, astronauts can pinpoint their location more precisely. The Moon has a dust tail. Although you may never have seen it, the Moon has a dust tail that stretches out along its orbit much like a comet. Only unlike a comet's tail, this lunar dust tail is very faint and difficult to detect directly. However, it is believed to be composed of dust and gas particles lifted from the lunar surface due to solar radiation. This lunar dust tail is thought to significantly impact the Moon's surface, as dust and particles can affect the chemical composition of the lunar surface and alter surface reflectivity. In addition, this tail of lunar dust may have implications for human and robotic exploration of the Moon. The dust can harm astronauts' health and interfere with the operation of electronic equipment and air purifiers. Although the existence of this lunar dust tail has long been theorized, its direct detection has been challenging due to its tenuous nature and interference from sunlight and Earth. However, with the help of advanced telescopes and NASA research, it is hoped that significant advances in the detection and characterization of this lunar dust tail can be made in the future. The Moon smells of burnt gunpowder. Most people associate the Moon with a desolate and lifeless landscape, but the truth is that several aspects of our natural satellite continue to surprise us. One of these aspects is its characteristic smell, described by astronauts who have visited the Moon as burnt gunpowder. Although it may seem strange, this aroma is due to the chemical composition of the lunar surface. The Moon has no atmosphere, meaning the surface is directly exposed to space and cosmic rays. This causes the chemical elements present on the surface, such as iron and titanium, to oxidize and produce chemical compounds, such as iron oxide and titanium dioxide. When astronauts bring samples from the lunar surface back to Earth, the smell of burnt gunpowder is given off due to the release of gases and chemicals produced when the samples are exposed to Earth's atmosphere. The fact that the Moon has a distinctive odor is just one of the mysteries our natural satellite continues to pose. We will likely discover more information about the Moon and its elements as we explore space. The only world other than Earth that humanity has been on. The Moon is the only object in the solar system that humans have visited, representing an impressive achievement in the history of space exploration. From NASA's first human crewed mission in 1969 to its last in 1972, only a handful of astronauts have set foot on the lunar surface, but the impact of these missions continues to reverberate. Human lunar missions have allowed scientists to collect a vast amount of data and samples from the Moon, allowing for a greater understanding of the formation and evolution of the solar system. In addition, these missions have also contributed significantly to the development of space technology, including life support systems, landing vehicles, and spacesuits. Despite advances in space exploration, the Moon remains the only object in the solar system that humans have visited. However, this could change shortly with plans for a crewed mission to Mars in the coming decades. Meanwhile, robotic exploration of the Moon continues, providing new insights and data on our natural satellite. Through detailed images, measurements, and analysis of the composition of the lunar surface, scientists are gaining a deeper understanding of the Moon's history and geology. Strange fluctuations in the Moon's gravitational field. It has been observed that the Moon has fluctuations in its gravitational field, which has generated significant interest in the scientific community. The Gravity mission, the Recovery and Interior Laboratory, GRAIL, launched in 2011, was one of the missions that helped to measure these fluctuations more accurately. The results indicated that the Moon does not have a homogeneous distribution of mass in its interior, which causes fluctuations in its gravitational field. The most widely accepted explanation for this phenomenon is that the Moon has many mascons, or mass concentrations below its surface. These were created by asteroid and comet impacts on the Moon, which created depressions and later filled with magma, generating a greater mass concentration in these areas. This causes gravity in these areas to be greater than in others, reflected in fluctuations in the gravitational field. Understanding these fluctuations in the Moon's gravitational field is essential for understanding the internal structure of the Moon and its geological evolution. It also has implications for future exploration of the Moon, since knowing its mass distribution is essential for planning missions and landing in safe areas. The moon has no seasons. Unlike the Earth, which has 4 seasons due to its axial tilt, the moon has no seasons. This lack of seasons on the moon is its lack of axial tilt. On Earth, the axial tilt of 23.5 degrees causes seasonal variations. This axial tilt determines how sunlight reaches different parts of the planet at different times of the year, affecting weather and day length. The moon, on the other hand, has an axial tilt of only 1.5 degrees, which means it receives virtually the same amount of sunlight throughout the year. This means there are no significant changes in day length or temperatures throughout the lunar year. However, the moon also experiences other phenomena related to its orbit, such as lunar and solar eclipses. During a lunar eclipse, the Earth comes between the sun and the moon, casting a shadow on the moon. During a solar eclipse, the moon comes between the Earth and the sun, casting a shadow on the Earth. These astronomical events can be observed from Earth and are a reminder of the complexity and beauty of the solar system. More meteor strikes on the dark side. The moon's dark side, which is technically the opposite side of Earth, looks quite different from the near side of our natural satellite. One of the most distinctive features is a more significant number of craters and impact marks on the surface. This is mainly because the moon's dark side is more threatened by impacts from asteroids and other space objects. The explanation is that being in a synchronized orbit with our planet, the moon always presents the same face towards the Earth, which means that the dark side is permanently oriented towards outer space, the place where the asteroids come from. This causes the moon to be more exposed to any approaching object since it is not protected by the Earth's atmosphere or the moon itself. In addition, the craters on the dark side are older and have not been covered by volcanic eruptions as on the moon's near side, allowing impacts by asteroids and other space objects to be better preserved. Studying these craters can provide valuable information about the history of the solar system's formation and how it has evolved. The moon is the 5th largest satellite in the solar system. The moon, the 5th largest satellite in the solar system, has a diameter of approximately 3,476 kilometers. It is the largest satellite relative to its host planet, since it represents approximately a quarter of the size of the Earth. The moon is smaller than the other 4 satellites in the solar system that are larger than it: Ganymede, Titan, Callisto, and Io. The moon is also relatively light, with a mass of only 1/8 of the mass of the Earth. One reason astronauts could jump during the Apollo missions is its low gravity. Despite its small size, the moon significantly affects Earth through its tidal effects. Although the moon is the 5th largest satellite in the solar system, it is the most significant relative to its planet, making it a unique and fascinating object in the night sky. There is frozen water at the poles of the moon. Since the 1990s, there has been speculation about the presence of water on the moon. In 2009, the L-CROSS, Lunar Crater Observation and Sensing Satellite from NASA, confirmed the presence of water in the form of ice in a crater at the moon's south pole. Since then, more research has been done to determine the amount and location of water on the moon. It is believed that the presence of water on the moon may result from several factors. First, the water could have been brought by asteroids and comets that impacted the lunar surface. Second, it is believed that the water may have been produced by the interaction of the solar wind with the moon's surface, resulting in the formation of hydrogen and oxygen. Finally, the presence of water may have resulted from early volcanic activity on the moon. The presence of water on the moon is an important discovery, as water is a valuable resource for space travel and human exploration. Additionally, the presence of water may help explain some of the phenomena observed on the moon, such as the changes in temperature at the lunar poles. Investigations into the presence of water on the moon continue, and plans are being developed to exploit this resource in future lunar missions. NASA and other space agencies are working on technologies to extract, purify, and use lunar water in space exploration. It also opens up the possibility that the moon will be a more habitable place for humans. The moon can affect seismic activity on Earth. The moon's influence on Earth's seismic activity has been debated among scientists for a long time. Although the scientific evidence is inconclusive, many studies suggest that the moon may affect earthquakes and volcanic activity on our planet. One of the most popular theories is that the moon's gravity may influence Earth's activity. Theory suggests that the moon's gravitational pull can stretch and compress the Earth, potentially triggering earthquakes and volcanic activity. Some studies have found a correlation between earthquakes and the position of the moon in its orbit, which supports this theory. Another theory suggests that the moon may indirectly affect seismic activity by affecting the Earth. When the moon is closer to Earth, Earth's gravitational pull is more significant, which can increase the height of the tides. This can put pressure on the Earth and trigger earthquakes and volcanic activity. Although the moon's influence on Earth's activity remains a research topic, most scientists agree that the two have some relationship. Understanding this relationship can help scientists predict and prevent future earthquakes and volcanic activity. A time capsule. Impact craters on the moon are a distinctive feature of the lunar landscape and may be of great scientific importance. Larger craters such as the South Pole Aitken Impact Crater, which is about 2,500 kilometers in diameter, may hold vital clues to the geological history of the solar system. Studying the craters can provide valuable information about the formation of the moon and the history of asteroid impacts in the solar system. For example, the most prominent craters may have been caused by impacts from planet-sized objects, which could help scientists better understand how the solar system formed and how it evolved. Furthermore, exploration of the craters on the moon may be of great importance for future space exploration, as they may serve as potential locations for establishing a lunar base. More extensive and deeper craters such as the Shackleton crater, which is more than 4 kilometers deep, can offer protection from solar and cosmic radiation and extreme temperature changes. The moon, our closest celestial companion, continues to be an object of fascination for scientists and hobbyists alike. What else can we learn from the most prominent craters on the moon? What other secrets are hidden in the polar regions? And you, would you like us to bring more mysteries about the moon? Or what other body in the solar system would you like us to talk about? Let us know your opinion with your valuable comment.